Hi, look at what I got. I got two NuTone IM5000 control boards. The NuTone IM5000 is the pared down selected call version of what originally was a NuTone IM5006. It took the place of the IM5006 when it was discontinued, and recently I happened across someone who had these two units. He had them up for sale as non-working for parts or repair only, and he actually said that someone else had looked at them and they deemed them, wait for it, unrepairable. What he was asking for them was more than I thought they were worth to take a chance on. So I made him an offer and he accepted it. Don't have a lot in these, and even if they turn out to be completely useless units and only possibly become parts units, it's still worth having a quick look at. So let's take a look at what we've got here, because they are actually each different. Most people don't realize there are early and late IM5000s. This is an early IM5000, and this is the later revised IM5000. They are both totally interchangeable. It doesn't matter which one you have or which one you need, because they'll work with all of the same remote stations that the other one will work with. It's just an update in the design a little bit and in how it was manufactured. If we take a quick look at them as they are now, this one looks like it's in pretty good shape. It seems to be at this moment complete, but we'll see about that. The heatsink cover is in place with the clear plastic cover on it. It's still clear. This one, you can tell the clear plastic cover has turned brown a little bit. I think you can see that, and that indicates that the heatsink assembly had gotten hot for a long enough period of time to discolor the plastic. So let's go ahead and take these off. I already took the screws out of them just so you didn't have to watch me do that. And just as a brief overview of what we're looking at to point out some of the differences, because to you they may look exactly the same, but they're not. The primary difference is some of the components and a lot of the component layouts are somewhat different. The part that seems to be the easiest to notice is one of the things that you'll notice right off the bat. The early ones have the blue relay, and the later ones have the orange relay. That's one way you can sort of tell. The other differences are little things. Like here, you've got these round black stickers, and these are actually over holes that are in the board where screws can go into the mounting plate that they sit on. This one doesn't have the screw in the middle. There is a screw under the OK sticker there. This one also has a screw hole in this corner up here. This one does not. Those are just little things that are easy to point out. The biggest difference is in this area and this area over here. You can see this integrated circuit here is sort of upper half of the board in from the edge about 1.5 inches, whereas the matching component on this one is right in the center of the board, is closer to the edge, and all the components around it have a different layout. It's just one of the ways you can tell. Sometimes you can also tell by the color of the connector. Usually the early ones have the blue connectors and the later ones have the green connectors, but this one seems to be backwards of that, so I don't know whether someone's changed those or whether that wasn't a real good indication of it. So let's take a look at each one of them and see what we might visually be able to see is wrong with them, and then we'll see what we can do with them. So in this close-up, you can see this is the early one, the one that was on the left, and some of the things I see right off the bat. Oh, and the point of this is whenever you get anything in, especially if it doesn't have a good history or it's just some random thing that you picked up somewhere, a good visual inspection is important because it gives you clues as to what it is you might expect to find if you try to hook it up. So what do I see right off the bat? Well, I see right here and here and here, someone's removed a bunch of ceramic filter capacitors, so someone's worked on it in the past. The other thing I see on this side, I don't see a lot of components that look like they've been changed, except maybe right here. These diodes, because of the way they're installed, they're not sitting flat on the board. They may have been replaced, as these two down here may have been replaced. But right down in here, we see a really bad thing has happened to this IM5000 board. So right here in this extra close-up view, we're looking at the interior of the power supply section of the IM5000, and you can see right here, this is a little op amp, and right here there's supposed to be its brother op amp sitting on the board, but actually what we have on the board is a big burnt area, and it's actually burnt to the point that I can actually take my screwdriver and stick it through the hole in the back of the board. So that's not good. It's cratered out and burned away the board. There isn't necessarily anything in this part of this set that should get hot enough for a long enough period of time to actually damage a board like this. So what I suspect has happened is this very well may be a lightning damaged unit, and it blew up the op amp here, and I actually have seen that before. In fact, I think I have one here. Let me get it and show you. So what I'm holding here is the same model of op amp actually. This one didn't come out of this IM5000. This actually came out of a customer's IM5006 that we have here at the shop. His also has lightning damage. And as you can see right here, there's a big old chunk blown out of the case. This is a confirmed lightning damage unit, and the lightning got into the set somehow. It did enough damage to actually explode the case of the little op amp. And here we're looking at the back of the same board, and down here this was the section where I said the ceramic capacitors have been removed. You can see all the little holes in the solder pads where the leads would have come through, and they're all empty. And if we look across this board, it tells somewhat of a story. If we move this way, right in here, you can see the copper has been exposed underneath the solder mask, which means somebody had done some testing and measuring probably for some reason down in there. And if we continue to go across, this is the microprocessor. If we go up here, here's that large integrated circuit next to the edge of the board that I pointed out earlier. This has been resoldered, as has this component, this other op amp. This is the one with the hole in the board right there. This, its neighbor, has been resoldered. If we go up here and we look across this section of the board, this all looks pretty original. You can always tell because factory or automated soldering has this even sort of dullish look to it, and hand soldering you always get brighter joints. This integrated circuit's been replaced. This one seems to be original, and I think I noticed that there's a few small probably transistors. There's one here that looks like it's been replaced. There's something here that's been replaced, and these are big power regulation transistors, and these may or may not have been soldered by hand. I think these were soldered in place by hand when the board was made, so you can't always tell by the solder joint. There's another transistor, or I think it's a voltage regulator down here, that looks like it's been either removed and checked and put back or replaced. So someone did a fair amount of work on this board, and if they deemed it to be unrepairable, it could very well be. The problem with a board like this is this damage right here. While it may be possible to get a op amp installed in there and affix it to the board so it's sturdy and make sure the traces are in good shape, it's kind of hard to do all of that and then use it as a service replacement or sell it to someone as a completed unit when it has this much physical damage. And actually repairing the fiberglass board itself, it's a lot of work for what it is, and it's in kind of a tough area, and it's really in bad shape. So this one most likely will be strictly a donor or parts unit. And as a donor unit, it even has fairly limited value. If we go across it and look at what we would rob off of it that might be of some kind of use, nothing so much here, nothing so much here, nothing here, nothing there. These two coil assemblies would be good to have, although it's doubtful that in any IM5000 any of these would ever go bad, but we would certainly probably keep them because we could. The wire connection standoffs, always good to have, but not that hard to come by. Nothing here, nothing here. Maybe these power transistors on here, although they're readily available. So, you know, the audio input jacks, since they're unique to this model, you don't have to try to find an exact replacement if you needed one, if someone broke one off or something. So that would be good. Some more output coils here. There isn't really little selector switch here and a reset button here. Yeah, maybe. There just isn't a lot on here. Virtually most everything that's on this board is something you can obtain new. So there doesn't have a lot of useful parts, especially if it is a lightning damaged unit. The problem with lightning damaged sets is lightning is completely and totally random. If it made its way into the board and it blew up the op amp, which is why the board is burnt, and we don't know that, I'm just guessing, then you don't know how much other damage is in the other ICs. And even if ICs still work today, if they've been weakened or stressed from the lightning, they could fail in the future. So it's not a good gamble to take. It has limited value. Some people would say, well, you can use the microprocessor off of it and put it on another board that has a bad microprocessor. Well, whether it's good or not, you wouldn't know until you tried. And also you have the same problem, which is if it was stressed by the lightning, it could fail suddenly at some time in the future. So not necessarily the best way to go. So this is board number 2. This is the one on the right. The visual inspection, the only thing I see on this is someone's removed the on-off switch, which is not a big deal. The on-off switches on these do tend to fail sometimes because they're not a very good brand, and that's not a terribly difficult thing to replace. I don't see on here anything that looks like anything else has been replaced. There is no burnt holes. The op amps look fine, so that's promising. This one is the one that had the cover with the discolored plastic over it, so it obviously has run warm for a period of time, but that's not an indication that there's anything specifically wrong with it. It's just sort of a general problem. So here's the back side of the same board. These are the openings in the board where the contacts for the switch come through, and if I scan across the board, I don't see anything that looks like anything's been reworked. This is the microprocessor here. If you were paying attention on the back of the first board, you'll see this is a different microprocessor than was used on the early models. And if I scan across this, I don't see a lot wrong with it. I don't see anything that's obviously missing or damaged, and I don't see that anyone has looked like they've touched it or done a lot of work on it. So it could be one of those units that maybe it does have a problem. Could be an ordinary problem. That would be swell. It came in and to whoever was doing the service work, and they had a replacement unit for it, and they sold it to the customer, and they got to keep this one, and it sat on the shelf for a long time, and then at some point they had another unit that had a bad switch, and they go, oh, I know what I'll do. We have that other one. We'll just rob a switch off of it. And once you do that, there's no way to turn it on, so there's no way to test it or work on it. And if they were busy and they couldn't be bothered, who knows? It could have sat on somebody's shelf for 10 years until I got it. This one looks like a good candidate to do a little bit of work on and see what we might have. So let's go ahead and put a switch in it and hook it up and see what it tells us. So here's our replacement switch. It's very similar to the ones that NuTone used. It doesn't have the little hieroglyphics on it for on and off, but you know, it says on the board on and off, so that's fine. There's 2 lugs on the bottom, and they just fit into the holes like this, so that's pretty simple. And we're going to go ahead and we'll solder this on real quick. You should be using a bigger tip because it's a large area, but it'll be fine. Once you get one of them tacked down, we can flow the second one more thoroughly. And when that one sets, you can always tell when it's cooled down and solidified because it'll go from shiny silver. You can sort of see the heat dissipate and it gradually turns into a duller silver. And once that side's in place, then we'll go ahead and reflow this other one again to make sure we get a good connection like that. So that's pretty easy. Let that one cool off. And now we're going to go ahead and we're going to hook it up and we're going to do some measurements and see what the measurements tell us. And there's our on-off switch. On, off, on, off. When it's on, the little red LED light right there will glow. You can see it on the end to tell you it's turned on. Okay, let's get this hooked up. Okay, so we're going to hook it up to our bench power supply. I'm going to make our connections here. Like that. And that's all we're going to hook up to it to start with. We're not going to hook up speakers or anything to it because we want to see what kind of condition it's in before we do something like that. I'm going to go ahead and set my multimeter to DC. I'm going to turn on my bench power supply, listen for the click, and now we're going to turn this on, and you might be able to see the red LED light is lit up. So what are we going to do? Well, the first test you do on an IM5000 is you want to measure the voltage output for the 6 connections that connect the control unit to the remote speakers. The way you do that is very simply, you're going to measure from ground. This is the ground lug here. You're going to measure from ground and go down the row and see what we have. So what do we have here? We have less than a volt. We have less than a volt. We have 0 volts. 0 volts there. Almost 0 there. And almost 0 there. This is one SICK IM5000. Is this hopeless? Is it beyond repair? Is it no hope of ever working again? Probably not. So what's the next thing we're going to measure? Well, the next thing we're going to measure there are a few little linear voltage regulators. There's one here and there's one down here. And we're going to measure those real quick because those are local power regulation parts. So the way a set like this is designed is you have a primary power supply that then sends power out to other parts of the set, and then other parts of the set may have their own local voltage regulation, and you need everything to be turned on. The idea is kind of like this part supplies the fundamental power, and it sends it to this part over here, and this little voltage regulator regulates it and supplies voltage to maybe this part of the board. If this is bad, then this isn't turning on, and then things don't work right. So what we're going to do is I put some little probe covers on because we're dealing with small parts in kind of tight areas, and we want to see, we don't want to short anything out. And what we're going to do is we're just going to measure, and indeed I have 5 volts there, which is what it should be, so that's good. This one down here is always a little hard to get to. That's why you use the probe covers. I talked to a lot of people. Okay, so down here we have less than a volt. So this one's not working properly. If we check the supply side of the voltage, it's only receiving 2 volts, which is way too low because it's a 5 volt regulator, so it requires more than 2 volts to come to it to make 5 volts out of it. It should be, I think, around 12. If we check this one over here for the supply voltage, we've got 13.5 volts. So this one probably about the same because that's how NuTone does things. So this one is fine. This one is low. So since this isn't working right, parts over here, sections of the board are probably not turning on. Then the other thing we want to do is we want to check this one down here because that's a primary, that's a 12 volt regulator. And if you have the probe covers, and what these are, so there's a standard probe end. And if you try to take this and fish it down into there, odds are you're going to short something out. And I hear from a lot of people and read a lot of things about, oh, I was setting the DC offset on my amplifier and my probe slipped, and then there was a spark, and then there was smoke, and now everything's dead. Oh, yeah. So you got to be careful. So the probe covers fit over the ends, standard ends of the probe, and basically it's a long sort of stiff piece of metal with a cover over it, and then the very, very tiny tip is exposed so you can make the connection, and this insulates it so you don't accidentally short it out. So if we do this carefully, I should be able to reach in here and measure. And we've got 25 volts coming in, and we've got almost 12 volts coming out. So this one's good and that one's on. So that tells us a lot. Or it tells me a lot. Probably doesn't tell you much at all. What does it tell me? Well, it tells me a couple things. It tells me that this set, while it has damage, probably is repairable. That's my guess at the moment. And the kinds of problems that it can have can be wide-ranging and vary a lot. What you want to do when you approach a repair like this is repair first and then rebuild. You never rebuild first and then repair, because common IM5000 rebuild consists of replacing all the electrolytic capacitors in the whole thing, a lot of the ceramic capacitors, all of the integrated circuits with the exception of the microprocessor, which is not replaceable, and replacing a lot of the diodes and things on the board. And if you do all of that and you do it correctly, you will have rebuilt it, and it'll be actually in some respects better than when it was brand new, and you'll be able to go off again and you'll probably get another 15 or 20 years out of it. It should last longer after all of that than what it was when it was brand new. The problem with doing that first is you're talking about replacing 60 some odd component, and every time you replace components first before you solve the problem, and the reason people would do that is because they're hoping that, well, these big capacitors here, these are the biggest ones, and those are bound to be the problem, so we'll replace those and then see what we get. Well, that's not going to help you any, I can tell you from experience. But what happens is every time you replace a part on here, you're introducing a variable into what you're trying to do, which is solve the problem of why it doesn't work correctly. And the variables, if you're adding 60 or 70 variables into the equation of what is wrong with it, it's a bad idea, because it becomes too overwhelmingly complex to try to reason your way through. What you really have to do is you have to go through the circuits, you have to identify which parts of the set power each of the different outputs here, and then go through that section of the board and figure out what's wrong with it and replace the parts that are bad and slowly bring it back to life one step at a time. That really is the key to working on something. Well, this is only one board. This is a reasonably complicated board compared to what most other intercoms are. You have to proceed slowly, and the way I approach it is I do one section at a time. Since the voltages here were all incorrect, all of them were incorrect, none of them were right, I'm not going to try to fix all of them at one time, because I know that each one of these is associated with a different section of the board. So what I'm going to do is I'm going to work on this, and I'm going to repair each output one at a time, and then gradually build on that until at the end, when you get the very last one fixed, it all works again. And once we get it to that point and it functions correctly, then we'll go through and replace all the age-related components and whatever else is left that hasn't been already replaced during the normal course of the repair. I'll be back for part 2. This will be part 1 of the ongoing saga of twin IM5000 control units. And when we get to part 2, I'll show you what I did. Okay, so a little time has passed, and I've done some work on our IM5000 board. I have it set back up. These are the connections for a door speaker, power connections up here. And if you remember, all our voltages here were wrong. This is just a connector I added onto the connection block so I can plug speakers into it. And so all the voltages here were wrong, and this little 5-volt regulator down here that's right at the edge of what you can see, it didn't have any voltage either. So let's go ahead and we'll turn it on. There's a little popping out of the door speaker. That's always a good sign. And first we'll measure our 5-volt regulator down here. That's not what I want. We're going to put our probe covers back on because we don't want to short anything out. Now if you remember down here, I think you can see that, I'll move it a little bit, this one right there, when we measured it before we had about 2 volts going in, and I forget how much coming out. It was not anywhere near 5, I remember that. So we'll go ahead and we'll measure this. So now our input voltage is 16.9, which is good. And if we measure our output voltage, we got 5.01, which is outstanding. We'll check this one over here also. Move this a little bit. This one that we checked previously, it was fine. So input voltage, oops, wrong side, is 14.3, and output is 5.1, so that's fine. Also, our 12 volt up here was fine before, so we're not going to worry about that. And now we're going to measure our voltages on our connector here. If you remember before, it was like less than 1, 0, 0, something, something, all less than 1 for the most part, if I remember correctly. I didn't write them down because it doesn't matter. So we'll go through these now. What do we have now? 2.7, 2.7, 19.9, 19.9, almost 8, and almost 3. And those are actually within the realm of what they're supposed to be. So with a little bit of work and having replaced this many parts, we've now brought it back to life. And now we have more or less the correct voltages, which is always the first step in doing any repair. First, number one rule when you're trying to fix something: measure voltages, see what's wrong, figure out why, and then fix it. So this number of parts have brought it back to the point where we seem to have mostly correct voltages. So now what we're going to do is we're going to hook it up to a couple remote stations and see what does and doesn't work. One thing to take note: you never, ever, ever, ever connect or disconnect anything to an IM5000 while it's powered up. You absolutely, positively have to turn it off. And I did. So now we'll go ahead and turn it back on. I've got my two normal everyday bench test speakers. I've got one here and I've got another one here, and they're hooked up. They're wired in a loop, and they're daisy chained together essentially. And we'll go ahead and power this up, and these should go sort of pop, 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 just like they did, and that's a good sign. So now what we can do is we can test the functions on these and see what is and isn't working. And the pop, pop, pop is a good thing. So basic checkout, we'll do all call, and that seems to work. If we do talk, nothing comes out of the second speaker, so that's not good. If we do a selective call, the other speaker is speaker 2. Oops, is speaker 2. It just errors. It doesn't connect. If we do speaker 1, it connects. But you're saying there isn't a speaker 1, or maybe this one's speaker 1. I'm confused. Well, it's a holdout in the software from the early days of an IM5006. An IM5006 by default was always station number 1. And they didn't change the firmware in the microprocessors, so station number 1 still exists, but there is no station number 1. So you can always call station number 1, but there is no station 1 to connect to, so nothing happens. But this is a clue, because if we can connect to station number 1, that shows that that's a function that works. But if we try to connect to station number 2, which is over there, it doesn't work. It errors out. So the system isn't seeing station number 2 for some reason. We can try door talk. That's the feedback from over there. If we push talk, it doesn't transmit. There is a pop in the speaker. It doesn't work. And if we feel our relay here, it's not energizing. And also, with my finger on it, it's getting kind of hot, which means that it's energized all the time, and that's why the conversation isn't going back and forth like it's supposed to. So that's a problem. If we go to station, this one, the second one, you'll notice that the busy light is stuck on and it's not supposed to be, so that's a problem. We might be able to clear that, but what we're going to do, the easiest way, was just going to turn it off. We'll let these drain down for a couple of seconds, and then we'll turn them back on. And now we'll try calling from the second station to the first station, which this one happens to be number 22. And that doesn't work. All call works, but there's no talk and no listen. Door won't connect. Monitor works, so that's something. Station 1 doesn't work either. So there's a communication problem between this unit and the control unit. So let's go ahead and turn this off, and that will be step number 2. So far, the only thing I've done to this is I've worked on the power supply section of this board. I haven't worked on any of the logic circuits or any of that yet, and those are the circuits that control how the remote speakers operate. So that's step number 2. Back in a bit. I'm back. So a little bit of time has passed, and I think I solved the problem, possibly, with the door talk relay, which was energized all the time and was getting hot, and we only had door communication in one direction. So I did some work on the board. Let's go ahead and turn it on and see what we get. We should get our 3 pops in our remote speakers. Yep, that's good. And if we go ahead and we do door talk, there'll be some feedback, but we'll turn the volume down a little bit. So, and now that might sound really bad, and it's very annoying, but it's just feedback because the speakers are so close to each other. It has nothing to do with how the system operates. So now we have both door, talk, and listen. The other problem that we had was you couldn't connect or communicate between the 2 remote speakers, and I noticed here right off the bat, and this is like last time, this is our second speaker, our busy light LED is still on, which it should not be because the system is not busy because it's not being used. So if I try to call speaker number 2, it errors. All call works. Yes, it does. But there's no talk and no listen from the remote speaker. And if I try to call this speaker from 2, doesn't connect. All call connects, but no talk. And if you listen to this. Listen in here. Okay, those 3 little poppy noises when you push the button and then again when you release the button, that indicates a communication problem between the remote speakers and with the IM5000. So that's our next job, is for me to figure out what I have to do. What did it take to get the door talk working properly? It took replacing these 3 parts. These 3 ICs. And these 3 ICs are in this section of the board because this is the section that has to do with the door talk and listen. Now it's on to the next problem and see if we can get the remote speakers to communicate. I've done some testing and measuring, and I think that we probably have the problem solved with communication between the remotes and so forth. So let's go ahead and power up, get our pops like we're supposed to, and let's go ahead and we'll try communicating with, this is speaker 22 with speaker 2 over there, and if we key it in, oh, sorry, that's 2. This is 22. It works. And now we can all call. And that works also. And if we go the other direction, we go from this one, which is 2, to 22. That works. All call. That works. Doors talk probably still should work. Sorry about all the feedback. I have solved the problem with having the remote speakers connect to each other and communicate. And to do that, we've got 3 more parts that were replaced. This section of this board has to do primarily with that type of problem. So that's where I looked, and I found 2 integrated circuits and a single little transistor that had failed. Now, based on all the problems that we've seen with this set so far, I'm pretty confident that this set had some type of probably lightning or storm damage. And I would guess, based on what I've seen, that it came down the wires from the door speaker outside, probably on the front porch, and it zapped the unit and caused all kinds of damage. One way we can test that is we can plug a chime module into it and see if the input for the chime module is active or not. So let me go ahead and grab a chime module. This is my bench testing chime module. This is a really old school chime module. This is probably from 1984 or 1985. I don't think there's a date code on it. But this was one of the original chime modules, and I keep it here on the workbench. It's been rebuilt and it's in good working order. So let's go ahead and plug it in. Of course, we have to turn it off because remember, you never ever plug anything into the system while it's on. So it's powered down. We'll go ahead and plug this in. And we'll get something to put here with, and we'll turn it back on. And if we're right, it should ring. And there you have it. So now our IM5000 control unit that was not repairable now seems to work. So what's left to do on this? Since it is most likely a lightning damaged unit, the correct thing to do at this point is to go through and replace all of the remaining integrated circuits in it. There'll be a whole raft of diodes that should be replaced. And after I do that, everything probably will still continue to work, and then it's time to replace all of the capacitors. Once that has been done and it's verified that it works correctly, it'll be a completely rebuilt and repaired IM5000. That's a pretty good deal. Even though the other one that came with this one is toast and it's got the big hole burned in the board, even with what I paid for both of them, this is still a good deal. And now this will be ready. It can be sold, or it can go in as a service replacement or something like that. I have more to do on it. I don't think I'm going to shoot any more of this video. We accomplished what the video's point was to see if it was repairable or not, and it turns out that it is. Seeing a pile of capacitors and things at the end isn't really that interesting. I hope you found this interesting, and perhaps it'll be helpful. If it is, please give it a thumbs up on YouTube, because that always helps. You know, you can always leave questions and comments down below. That's appreciated, and I do answer all of the questions and comments. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.